Right, apologies for this presentation, but this is what you get stuck with if you end up with the same president year after year. But I've done presidential addresses on things that I know about, like steely stuff and decarbonisation stuff, and I've done other talks at times about cement and various stuff. So, not wanting to repeat myself, I had to think of something else to talk about. So the topic that I chose is to pose the question: is there a real future for industrial R&D? And the word in real is in italics for reasons that I think will be pretty obvious. AI is not a subject where I am the world's greatest expert, but like many of us, we all use it, we all work with it, we all have colleagues who work with it. So I don't imagine that I'm going to impart any great pearls of learning or new knowledge to anybody today. What I'm more interested in is to try and provoke some sort of debate and discussion around the subject, what we think of it, maybe what we ought to be thinking about, but don't often put in the time to think about. So I plan to look at the shape of traditional R&D and the increasing capability of AI and virtual tools to do some or all or more of that. Is it just glorified number crunching, or is real ingenuity actually programmable? And are great discoveries just made by incremental insight into the data, or is there something intangibly human involved in that? So start off with something that I borrowed from the Encyclopedia Britannica, which is an illustration of the difference between complex behavior and intelligence. So this little chap is a digger wasp, and she goes off and collects food, and she brings it back to her little burrow to feed her brood or whatever might be inside, and she drops it off at the entrance to the burrow. Then she checks inside the burrow that everything's safe, comes back out, picks up the food, takes it in. That all sounds fairly intelligent, but is that really intelligence? So what you find is, if you then move that piece of food a couple of inches, while she's in the burrow, when she comes out, she thinks, oh, food's not there. Oh, it's over there. I'll go and get it. She comes back to the burrow, puts it down, goes back into the burrow, checks again. And however many times you move it, she does that. So that's what appears to be a complex behavior, but it's learned behavior. It's not what we call intelligent behavior, because there is no measure of reacting to changed circumstances or being adaptive in that. So psychologists generally say intelligence isn't just about single traits, but the combination of different abilities and the ability to adjust and react. And AI's focusing on those sort of components: learning, reasoning, problem solving, perception, and using language. And we're increasingly coming across those in our everyday life. And artificial intelligence enables computers and machines to simulate human learning. Not telling you anything you don't know there, but what makes us human is sensory perception. And if you go back 20 or 30 years, machine learning, AI, neural networks, it was all about numerical data and processing and pulling things in. But actually, if you think of the sensors that we now have that are hooked up to these systems, AI is in a way able to see, hear, smell, touch, and even taste. So it's getting closer to humanity. We have systems that understand and respond to language. They learn from data. They make recommendations, and they can act autonomously in some cases. And the more recent breakthroughs on AI have focused on more on the sort of verbal and communication side sides. So we've got technology that with adaptive AI that's now able to create original text, images, video, and other content, but based on what it's learned. So it looks increasingly human. A couple of definitions, they're pretty much what you'd expect. Ability to perform tasks commonly associated with intelligent beings. The term is much older than I realized it was. The first reference to these sort of techniques under the banner of artificial intelligence dates back as far as 1956, so getting on for 70 years ago. Again, looking at ancient history, one of the big landmarks was when the first, deep blue chess computer beat the reigning world champion. That was back in 1997. At that stage, it was able to search ahead typically to a depth of 6 to 8 moves if it was a mundane phase in the game. If it looked like being a critical point, it could look as far as 20 moves ahead, but it had the discretion to pick and choose how deeply it needed to study. These days, that level of processing and insight would be regarded as pretty trivial. But even back in 1997, it could outthink the world champion in terms of chess playing. Little bit about how things developed. So starting in the 1950s, the early stuff was really about data processing with fairly hitherto unprecedented levels of complexity. That developed into machine learning around about the 1980s with neural networks and fuzzy logic and case-based reasoning and so on and so forth. Again, that was structured learning to what we regard as fairly formulaic algorithms and code. As we got into the 2000s, we went into more deep learning with knowledge trees and branching off into different ways of associating data that come closer to mimic the way that we make connections in the human brain. And where we are now, there's increasing interest in generative AI, which is AI that supposedly creates original content. And also we're no longer talking about data simply being streams of numbers and scientific values. We're analyzing things from language and text sources, images, sounds, semantic text. My phone gave me a shock a couple of months ago when I was having lunch outside one day, and a nice friendly dog came up to try and persuade me to give it some food, and I took a photograph of it for my daughter. I'd no sooner done that when the phone said, "Oh, I see you've just taken a picture of a dog. Would you like me to show you all the other pictures of dogs that you've taken on this phone?" And I never downloaded an app or did anything to tell my phone that it wanted to do that, but it decided that it wanted to have that conversation with me. So generative AI is increasingly making content. We've had on some of these meetings in the past, or certainly with CIE council meetings, examples where somebody in the group who's been online has had one of these applications on their phone, which is or on their laptop, that has decided, well, it's going to not only record the meeting but transcribe it, make some notes, and create an actions list. And doesn't always get it right, but that's what the technology can do. So common, it's hardly, we hardly even recognize that it's around us, but it's pretty well all around us. So what about R&D? Traditional stages of R&D, you have a challenge, you generate some ideas, refine them. What you don't know, you think, well, I better find out. So you do some basic research to test the concept. That goes to applied research. If it's still going well, you then start to get into the stages of development. Innovation, the definition I tend to think of for innovation is now make that idea into something useful that has a practical or monetary value, and then you're into scale up and prototyping, and it's delivered by these guys, expert scientists, technicians. There's nothing in there except possibly defining the initial theoretical challenge, where you couldn't conceive of some way in which machine learning or AI could play a significant part, although it tends to be the ones in the middle to top end where it happens happens most. But there's very little there beyond the original challenge that AI isn't now beginning to play a role in. So what does that mean in terms of us as engineers, scientists, in terms of what the future requirements are? Well, experts are always going to be important, but maybe fewer of them, or that experts could concentrate much more on doing their expertise than in doing the more mundane churning of the handle. And likewise for scientists. Increased role for IT specialists? Well, pretty clearly, because they develop these IT systems. But actually, in terms of usage, these guys are often every bit as capable as the AI specialists. So is that going to put us into a future where what we need is maybe a greater focus on intelligent generalists rather than experts? We always will need experts, but is the balance of numbers going to change? It's a question. I'm not suggesting that have an answer. Anyway, I posed some questions, a few headline applications. Again, nothing you haven't come across. Self-driving vehicles. Government posted this in 2024, I think. Self-driving vehicles to be on the roads by 2026. Well, maybe that's a bit over ambitious, but it's going to happen. It's no longer an if maybe pipe dream. The general view is it will happen. The question is when and how, and how will it be regulated? And it may happen sooner or later, depending on public perception and media coverage of safety issues. I mean, we've had some coverage of autonomous cars doing some daft things, and that will easily put the brakes on the developments. But human perception and statistics don't always match up. I suspect that already the accident rates on autonomous cars are probably lower than they are for human-driven cars, but that's not the way we perceive things or make decisions. But anyway, it's there, and the range of variables that has to be processed is quite extensive, as you can see. So that was one. We now got AI tools that can diagnose cancer. So it can look at scans that have gone on in the hospitals. It can differentiate between the healthy tissue and the cancers and tell you which cancer it is. And following on from that, it can therefore advise on treatment, and it can predict survival rates. And it can do it faster than human processors, not with 100% accuracy, but actually with a higher accuracy than many of the human processors, although we are not yet willing to hand over to AI to say, well, yeah, we'll take that as verbatim and away we go. We do need to check and challenge it. And over time, these sort of tools will come in increasingly, but it will require things to be put in place. There are projections that suggest that the NHS is going to need just short of 18,000 digital and data specialists by 2030 if we're going to go down these sort of routes. So yes, it might be replacing some jobs, but it's creating some others. And we need to build the infrastructure for that. Fortunately, things like radiology are already digitized measurements anyway. And we need to have managers and leaders willing to take it on. Anything to do with healthcare or affecting the public, you have to be seen to be open, fair, and honest. So need to detect effectively, regardless of ethnicity, sex, or other characteristics. Otherwise, you risk losing public trust. You also lose public trust if you get the diagnosis wrong. Another health service example is there's something called the National Biobank, which is a voluntary scheme where something like 500,000 volunteers, including myself, and judging by the nods, probably Sue as well, volunteer every now and again to be scanned from head to toe in every possible way, and also do hearing and eyesight and mental agility and blood tests and everything else to build up data, which is used to look at the health profile across the country, typically how histories change with aging and so forth, in order to then focus treatment and resource in a more effective way in the future. You know, if you've worked out from the data that only a small subsection of the population are susceptible to X, you don't need to blanket test the entire population for X in future. And also it will give you information on what the frequency of testing is and so on and so forth. And I actually find it quite entertaining having some of these tests performed on me, seeing whether I can remember a 12-digit number backwards and so on and so forth. And then there's other uses of AI. So you can now go online and find AI mental health counseling and advice and so forth, which gets a lot of criticism and scrutiny as to how trustworthy and how wise it is. But the fact is, it's there. It's right that it should get the scrutiny, but it's not going to go away. So can AI think like a human? Can it empathize? Well, if you're going to a psychiatrist, you'd hope that they can empathize. AI can certainly appear to do that. Is that really empathetic? That's one of these questions. But then, is empathy a human trait, or is it something that we have learned? Have we simply programmed ourselves? I don't know. So our emotions really matters of conscious choice, or are they learned behaviors? Is anything that we do a matter of conscious choice? So questions down the bottom: can AI be truly original? Well, that's open to debate. But I'd say it's also open to debate how many of our decisions are truly original and how many are embedded in the environment we've grown up with. Where's the recent focus? The most recent focus is around connectivity between disparate systems, making systems self-learning rather than having to be pointed in the direction you want them to go, looking at semantics, text, verbal inputs and outputs. Even in industrial applications, we're no longer just putting in the current and voltage and temperature data. We're now working in things about the 3 or 4 words of comment that the operator wrote on the log sheet that day, and progressing some of these softer pieces of information along with the hard data. We've now got large language models that are not just looking for the facts and figures, but trying to capture latent information in literature. Time, surprisingly, was a difficulty with using AI on many data systems, marrying up both small changes in the time reference in data from different aspects, but also to recognize how and where and when time is an important variable in itself. It sounds strange, but that was a major weakness in past neural network systems. And we've got things like model context protocols that allow connections between more disparate sources of data. So what about control? Is the genie out of the bottle? You've got some professors like Geoffrey Hinton who say AI could make humans extinct, others who say not. The IMF analysis warns that it could affect nearly 40% of jobs. Not necessarily badly in all cases, but could affect nearly 40% of jobs, but more interestingly, widen global financial inequality. So the ones who have the knowledge and the ability will find it a good thing, and others could be left behind. So what are we doing about governing it? The EU has produced the first really substantive piece of legislation to regulate AI, and that's largely about providing protection from risks. And it focuses mainly on individual rights and freedoms and protecting societal structures. So there's about 80 odd pages of impenetrable text, which I won't go into, but some of the areas that are specifically highlighted are protection of data around biometrics, protection of critical infrastructure. You can read the list. But it's all about people and society. Surprisingly absent, or maybe not surprisingly absent, is military application is not covered. I've referred to Asimov's 3 laws of robotics, which he first postulated in the 1940s about how intelligent systems would be programmed so they couldn't possibly harm human beings, and therefore we'd all be safe. And there are umpteen sci-fi films on that sort of subject, but insight into human nature, we specifically exclude it from the legislation that we've passed on control of AI. This snippet here is from the US military. I mean, we think that the Russians are using drones in Ukraine to recognize and target and kill people. But so how trustworthy are humans to control AI? Don't know. This you can't possibly read. It's a cognitive bias codex. It basically has a load of words around a brain about different things we might consider and how we make decisions. So we worry about AI ethics because we think, well, that's a problem. We don't trust AI. But what if AI ethics might actually be superior to humans? Because humans have cognitive bias, and in a real world, the decisions we make are very often not rational. So I couldn't possibly go into all the detail on there, but just as a subset of one corner, we notice things that are already primed in our memory. If something's bizarre or visually striking, we give it higher weight than if it's just boring and mundane. We notice when something changes. We're drawn to details that confirm our own existing beliefs. we notice flaws in others more readily than we notice flaws in ourselves. That's how humans make decisions. So we worry about AI, but I think we also need to worry, and fortunately we do worry about how we arrive at decisions ourselves. Future skill sets, what's going to be comparatively increasing importance compared to what we had in the past. Clearly, development of digital R&D skills, things around impact delivery, collaboration, open research and communication. And since the keynote around machine learning and AI is about connectivity and access to data, then these gain importance compared to the traditional academic route of individual excellence and working in isolation or small groups. But in terms of industrial R&D and getting things applied in engineering, that takes us out of our comfort zone, because the idea of confidentiality, what is shareable, what isn't shareable, what you're comfortable to be in the public domain, all comes into question. And I'm not sure whether our legislations and protections have caught up. So in terms of IP, you can't patent an algorithm. You can patent the package or application that it goes into. But if an AI tool, for example, can generate multiple new patentable formulations for a chemical or a metal alloy and churn them out 10 times or 100 times faster than traditional R&D, who is the inventor? Is it the person who developed the system? Is it the person who told it what to look at? You could very rapidly end up with the balance of power in terms of who owns what IP looking very, very different to the way that it's traditionally looked. So are the current IP rules going to be fit for purpose? Closer to home, if I think about my own experience within the steel industry, early work on advanced statistical networks, neural networks, fuzzy logic, etc., first began in the steel industry in the 1980s. Stuart will claim that he did the first, but well, I won't disagree with him, because I don't know of another one. But the first one I got involved in was in the early 90s, but certainly going back a long way and very much business as usual now. And that was on steel plant and blast furnace optimization, and later on blast furnace optimization. Later moved into things like quality prediction, process control. More recently, we get into areas such as digital twinning, integration of plant systems, progression towards smart factory. Some examples listed down towards the bottom. Alloy development and rapid prototyping. Parameters you need to look at: the chemistry and elements, chemical balance, the pyrometallurgical route, the casting regime, thermomechanical treatment. And traditional approach is you have experts who know something about this and have an idea which way to go. But even experts struggle when confronted with multi-component interactions beyond 3 or 4 variables. It's difficult enough looking at a ternary phase diagram. Looking at something with more than 3 phases gets distinctly more difficult. But machine learning isn't dimensionally constrained. So there are now projects in many of the UK universities. One I've been associated with is Comet at Swansea, that uses multi-component machine learning to assess thousands of potential combinations to make a new alloy. Very rapidly, that will say that 95% of these are completely useless, but 5% might be worth looking at. And then instead of going into traditional experimentation, they then go into 3D printing to lay down a test piece about the size of a striker pad on a matchstick, consolidate it through a set of rollers, do property measurements, and they hone down the 5% of possibles into maybe 1% of promisings, and then you go on to the traditional melt it, cast it, do the full-blown testing on it. So there's savings in time, materials, cost, and risk. And although that example was about metals, the same applies to formulations in chemistry or production of many other materials. In terms of optimizing the factory itself, basically, if it moves or produces some sort of output, monitor it, sense it, apply sensors to it, gather the data and get the things to talk to each other. It's a complicated slide, and I'm not going to go through it, but the gist will not be news to anybody. Challenges for established industry is that it's great to design a brand new plant. So I'm sure all your new plants, Steve, will be wonderful, but that's not the world we live in. We've got legacy equipment from many different suppliers. We've got to make them all talk to each other. So connectivity and linking together is a key thing. I think the ground rules have changed. If we went back 10 years, there'd be large suppliers of software who would try to tie you down to their system to do everything. There's now a lot of open AI type applications that you can use. So tying these systems together isn't tying you down to a few big players anymore. Data validation, what's useful and what isn't, used to be a big problem. Increasingly, AI systems can now do their own analysis of how good, bad, or indifferent the data is. It used to be a big chore to actually sift through it and tell the system what it could or couldn't use. And then the way we can output it, visualization, we can use augmented or virtual reality. We can create what we call digital twins of processes and optimize around those. And in gathering the data, we still need to take cognizance of the fact we're in hostile environments. So back where I work, we've scanned and digitized our pilot steel plant. So if it's there, we've scanned it. If it moves or produces a signal, we've set things in place to log it. And we've taught systems to recognize things. So we scan something like a ladle, and now we can recognize that's a ladle. And when it's a ladle of metal, we can look at it and talk to it and say, tell us what the temperature is in that ladle and tell us what the chemistry was last time you took a sample. So we've done that around the whole plant. And where augmented reality comes in, we can then use that to communicate with other systems. So if the operator wants to wear a pair of smart glasses with a microphone and a little screen on, he can look at the ladle and he'll say, tell me the temperature, tell me the last analysis, as I said. Or he could look at some part of the plant, the straightener on the casting machine, and say, show me the GA drawing for this, or show me the operating procedure for that. And so he could do that in his eye line, or he could transmit the image that he was looking at to some expert sitting in the supplier's office in Sheffield or Dusseldorf or wherever and say, I've got a problem, what do I do next? So interconnectivity really does give us a lot of options, and we can do VR tours, etc., etc. We've digitized or in the process of digitizing a lot of our records, but in terms of the processing, as I said, it's no longer just about the hard data. We can even use some of the more recent advances to process operator comments, and they can go into the learning process as well. So I've waffled on for a long time. I won't go into detail about that. In terms of R&D funding these days, the expectation of seeing AI is now the norm. This refers to a particular call for 100 million from Horizon Europe about development of AI. It's now rather unusual that there's a call about development of AI. Usually the calls are just about development of something else, and AI is expected to be in there as a work package. I'm an evaluator for Horizon proposals for big ticket items in steel, cement, foundation industries, and in terms of evaluator guidance, there's no longer a question that says, well, are they using AI? The question's really, are they using the most appropriate type of AI for the job, and is the work package big enough? It's just accepted as being part of everything. So parting thoughts, it was always about extracting knowledge and understanding data, even before we had AI. But the theoretical knowledge and the experimentation we do are just tools that we use to first determine what we want to look at, whether it's worth looking at, and if there's any missing data, what experimentation we need to get it and process it. That was how we always used to work. AI helps us do that much more efficiently, but we still need experimentation, because the proof of the pudding is at the end. Something I didn't talk about is standards. You know, if you can develop a new steel grade or a new pharmaceutical in 2 weeks instead of 10 years, that's great, but you can't put it out into an unsuspecting public without having the testing regime and the acceptance to know that it's safe. And it will be interesting to see how some of those things change in the future, because a lot of those prescribe really long periods of testing before acceptance. So it'll be interesting to see how that goes. So we will still need experimentation, but AI allows us to be more selective, more focused, and to weed out and discard a lot of the stuff that had a low chance of success and not waste our time on it. You can look at that 2 ways. A positive way is, well, that means it can just accelerate R&D because we focus on what's fruitful and we can achieve more with the same amount of effort. The concern with some of our more traditional industries in particular is that they may be content to trade off the efficiency improvement that this brings to do the same amount of work but with reduced R&D spend, in which case they'll probably be overtaken by more enlightened competitors elsewhere. But we'll see which way they jump on that. Consensus is that AI processing capacity is going to surpass human ability in many areas. The challenge is how we're going to manage that. Industry is widely applying the tools. Looking at what's around, I suspect that the industries we tend to focus on, the manufacturing industries, are not at the forefront. The real pace of growth is in the wider economy and societal context. There's more money to be made on influencing what you look at on your phone and your TV than there is on in how you make a steel lintel. Generative AI, how far can it go? We don't know. It already creates surprises, and there'll be much debate on the aspects around ethics and regulation. But what we do know with AI and machine learning is that over the decades that we've been working on it, it has consistently outpaced the predictions that we've put on it. And so those are my parting thoughts.